Okay, we're going to be looking at annuities in terms of geometric series. So we're going to be using those geometric series formulae that we've learnt before. Now I'm going to teach this exercise using two different methods. I've only made this method one, because it's the one that your textbook uses in their examples. I actually prefer method two. Method two is a little bit harder to get your head around, but it's useful in more situations. This first method, it's useful in these particular type of examples, but method two works in every example. So let's have a look at method one to begin with. It will be useful for this exercise, okay, but it may not be useful in future exercises. So we're looking at $300 being invested at the end of each month, earning 18% per annum interest and paid monthly. How much will it be worth after 15 years? So everything's per month. So just as a side point, just to mention now, if this 18% per annum was paid annually, then that $300 being invested each month, you get 12 lots of $300 and then a lot of interest. So it'd be just as easy to say $3,600 a year at 18% per annum. But that's not this situation. That's just a side point, just going off on a bit of a tangent. Okay, so let's have a look. Always write down your rate. Okay, so 18% per annum is 0.18. We have to divide that by 12 because it's per month. Okay, and that is 0.015 as a decimal. And our N, it's 15 years times 12, okay? So that's 180 months. That's per month. Everything's per month. Very important, your R and your N are per month. Okay, so here's how method one works. We put in $300. Now that's put in at the start of the month, the start of the very beginning amount. I'll just say A1. Now that $300 is going to be there for the whole 15 years, but because it was put in at the end of the month, it did miss out on the first month's interest. So they're going to be 179 months of interest on that $300. So just like compound interest, it's 1 plus our rate, 0.15, and our power will be 179. It's going to earn interest for 179 months. Now, I don't really like this A actually, because we use our A1 more so in the future in the other method. I might just call it X1. So our X2 is the amount invested at the end of the second month. So we've got $300. Now that amount, that $300, that's going to earn interest on it, just like compound interest. It's put in at the end of the second month, so it misses out on 2 months worth of interest. So it'll get 178 months worth of interest. X3 in the same way would get 177 months worth of interest. And that will just keep going and going and going. So down the bottom somewhere, if I go to X 180, my very, very last amount, that's $300. It's put in right at the very end. So that's going to get 0 months worth of interest. Okay, that's basically 300. 300 times 1. Remember, anything to the power of 0 equals 1, it's 300. Now, the future value of that annuity is going to be X1 plus X2 plus X3. It's all of those added together up to X180. There are 180 lots that have been put in at the end of each month. Okay, and so 180 payments. So we need to add those all up. So we had 300 times 1.015 to the power of 179 was our X1, plus 300 times 1.015 to the 178, plus 300 1.015 to the power of 0. Now, the easiest way to do these calculations as a geometric series is actually to turn that around. So we're going to put this figure first. So our first one is 300 times 1. Our second one is 300 with one lot of interest to the power of 1. Okay. Our next one would be 300 with 2 lots of interest. Okay, we're going backwards. And it keeps going, and our last one is 300 times 1.015 to the 179. Now, interestingly, this can be compared with our Tn formula, right? A to the n minus 1. A is 300, R is this number here, this is n minus 1. Now, if we want the sum of all of that, we're going to use our geometric formula, right? Now, our R is bigger than 1, so we want the R to the n minus formula, because remember, we want our denominator to be a positive number. If you minus 1, that's what you're going to get. So our A is 300, our R is 1.015, our N, I know we get the 179 here, don't let that confuse you, please. That's our n minus 1. Altogether, we have 0, 1, 2, up to 179. Our n is that 180. Be very careful with that. It's very easy to get lost and confused on that. Okay, our n is 180. So putting it into that formula, A is 300, 1.015 to the power of n minus 1. So remember, the T formula has n minus 1, but the S formula just has n. And they're on your reference sheet, so you can look at those. Over 1.015 minus 1. And if you put that all into your calculator exactly like that, you're going to get 99386.46. That's how much it's worth after 15 years.